The IM3 4.2 Extra Practice Number 3 Solutions on Quadratic Formula. There's a puzzle that goes with this one. Let's go ahead and check that out. So for the puzzle that goes with the extra credit, we're trying to ask the question, or trying to answer the question, what is a metaphor? So that is the riddle. The idea is that we've got these 11 different quadratic equations. We need to solve them using the quadratic formula would be a good idea. And then once we find the solution, find that solution down here, cross out the letters above that solution, and then whatever's left over, print that out in these boxes to spell the answer. All right, let's give this a shot. So here we go with problem number 1. Again, we're trying to solve this for x using the quadratic formula. On all these problems, I'm going to write out the quadratic formula. So that's, in this case, going to be x equals negative b plus or minus square root of b squared minus 4ac all over 2a. And there's lots of lovely videos proving that that formula actually works. But for our purposes, we're going to write it and use it and go into the mechanics of simplifying it. So we're also going to make sure that we're in standard form, decreasing order of exponents and zeroed out on the other side. And if we're not in that form, we better put it in that form before plugging into this formula. Now we are in standard form for this one, so I can just plug in a, b, and c as is. So I'm going to have negative b, that's negative 4 in this case, plus or minus square root of 4 squared, minus 4 times, we have an invisible a value here of 1, and then our c value, that's the constant, is going to be 3. And then down below we have 2 times that a value, that x squared coefficient of 1. All right, we have to simplify this. We're always going to have to simplify it to match an answer. So we've got negative 4, and then we've got, this inside here is going to be 16 minus 4 times 1 times 3, that's going to be 12, all over 2 times 1, which is 2. So this is negative 4 plus or minus the square root of 4, all over 2. So negative 4 plus or minus 2 over 2. And now we have to go ahead and simplify this. So we get 2 branches on here. We have negative 4 plus 2 over 2, so that's going to be negative 2 over 2, which is negative 1. And we also end up with negative 4 minus 2, which is negative 6 over 2. And that reduces to negative 3. So we're looking for negative 1 and negative 3 in our answer box here. I see that right here under the RIT, so that's what we're going to end up crossing off for this one. And I've got the boxes down below on the puzzle. We'll just fill it all in once we've crossed off everything for all 11 problems. All right, let's keep going. So here we go with the number 2 problem. We've got our quadratic formula again. And this time for negative b, I've got negative 7. That whole thing goes in there, including the negative, plus or minus square root of negative 7 squared. And I use a parentheses around that, otherwise it is going to be something different numerically. And then I have to subtract 4 times the a value is invisible 1 again, times my c value, this time of 10, all over 2 times the a value 1. So simplifying, negative 7 is 7, plus or minus square root of, this is going to be 49, minus 4 times 1 times 10, so that's going to be minus 40, all over 2. 49 minus 40 is 9, and then the square root of 9, that works out neatly, that's 3. So we have 7 plus or minus 3 over 2, which we can now simplify into 2 more specific answers. We've got 7 plus 3, which is 10. 10 over 2 is going to be 5, so that's one of our answers. We also have 7 minus 3, or 4, over 2, and 4 over 2 reduces to 2. So we've got 5, we've got 2. That's actually the very first box here, so let's cross out the 1, and then we keep going. Here we go with another problem. Now you might have been noticing and thinking as we go that, hey, I probably could have solved these other ones by factoring, and you're right. If you end up with a number or answers that are not radical form, like this weird plus or minus square root of 13 business, then you definitely could have solved it by factoring, and this one is no exception. We could do this in under a minute by factoring, no problem. But they want us to use quadratic formula. They're not going to know one way or another, but it just feels kind of like cheating not to follow the instructions. So here's quadratic formula, just to show that it works on even simpler problems like this. So we have negative 5 plus or minus the square root of 5 squared, minus 4 times invisible 1 again, times c value of 6, all over 2 times 1. So that's going to be negative 5 plus or minus square root of 25. And let's see, 4 times 6 times 1, that's 24, so minus 24, all over 2. Well, 25 minus 24 is 1. Square root of 1 is still 1. So we've got negative 5 plus or minus 1 over 2. So negative 5 plus 1 is going to be negative 4. And if I divide that by 2, I get my answer of negative 2. Negative 5 minus 1 is negative 3. Dividing that by 2 gives me, or negative 6, I should say rather. Dividing negative 6 by 2 gives me negative 3. I was thinking too far ahead there. So we have negative 2 and negative 3. That's this ASL box. Let's cross that out, and on we go. For this next one, using our quadratic formula, we have negative 3 plus or minus square root of negative 3 squared minus 4 times the a value 1 times the c value negative 4, all over 2 times a value of 1. And then we've got negative 3 is really 3, plus or minus square root of, this is 9. Negative 4 times 1 times another negative 4 is going to give us a positive 16, all over 2. 9 plus 16 is 25. The square root of 25 is 5. So we've got 3 plus 5 over 2. That's going to be 8 over 2, which is 4. And 3 minus 5 over 2, that's going to be negative 2 over 2, which comes out to negative 1. 4 and negative 1 is down in the lower right corner, so no more ing on this one. For this next problem, now they're mixing it up a little bit. We've got y instead of x. So I'm going to be fancy and write y equals whatever this quadratic formula business is. But it really just functions exactly the same. It's just we're using y instead of x for the variable. So we end up with negative 2, because this is in standard form, so we're good to plug those in. Negative 2 plus or minus square root of 2 squared minus 4 times a value of 1, still 1 there, times negative 8 for my c value, all over 2 times 1. So that's negative 2 plus or minus square root of 4, and minus 4 times 1 times negative 8, that's a positive 32. So 4 plus 32, all over 2. 4 plus 32 is conveniently 36. Convenient because the square root of 36 is just the whole number 6. So we end up with negative 2 plus 6 over 2, that's 4 over 2, which is 2. And negative 6 minus, or negative 2 minus 6, or negative 8 over 2, which comes out to negative 4. So negative 4, positive 2. I see that right here in the middle, so no more met. And on we go. Okay, the game is changing a little bit. Up to this point, every single problem we've done was factorable. You will very quickly see on this one that we cannot factor it. If I'm looking for two things that multiply to 2 and add up to negative 5, you're not going to be able to find numbers like that. So let's go ahead and use the quadratic formula. I mean, we were going to anyway, but we know we need it now. So we've got negative 5 plus or minus square root of negative 5 squared minus 4 times the a value 1, still 1, times the c value 2, all over the a value 1 times 2. So this is positive 5 plus or minus square root of 25. This is going to be minus 8 in here, all over 2. 25 minus 8 is 17. 17 is not a perfect square, and it doesn't have any perfect square factors either. So 5 plus or minus radical 17 over 2 is as good as this one gets. And I see that whole answer down here with this GLE, so that one is getting crossed off. On this next problem, they're mixing it up again and giving us a D instead of an X. At least they didn't give us an A, B, or C. That would be really confusing. So here's our quadratic formula with D equals all that stuff. So then we have the negative B values, or negative 3, plus or minus square root of 3 squared, minus 4 times a value of 1 again, times negative 7 for our C, all over 2 times 1. So that's going to be negative 3 plus or minus the square root of 9. And then negative 4 times 1 times negative 7, that's positive 28 that we're adding there, all over 2. 9 plus 28 is going to be 37. 37 is not a perfect square, and it's also got no perfect square factors. So this is the final answer then. We can't simplify that. So it looks like ick is the answer that we're going to be crossing off here, and good riddance. I mean, who wants ick in their answer anyway? For number 8, things continue to change. We're back to using x, but for the first time, we have a squared coefficient that's not 1. No invisible 1 here. We've got a 2 this time. So this ought to be interesting. So using our quadratic formula, we've got negative b value of negative 5 plus or minus square root of negative 5 squared, so nothing super different, minus 4 times, now the a value is 2. We have 2x squared, times the c value of 2, all over 2 times the a value of 2. A lot of 2's going on here. So we've got positive 5 plus or minus square root of 25, and then minus 4 times 2 is negative 8, times another 2 is negative 16, all over 2 times 2, all over 4. 25 minus 16 is going to give us 9. The square root of that is 3. So we have 5 plus 3 over 4, that's 8 over 4, which reduces to 2. And now we have 5 minus 3 over 4, that's going to be 2 over 4, which reduces to 1/2. So this is our first time getting a fractional answer. So we have 2 and we have 1/2. And I see both of those answers down in the lower left corner, so the boy is going away. All right, let's use our quadratic formula on this one. Again, I don't know if it's factorable or not, but it doesn't matter. They just want us to use it. So there we go, n equals all that stuff. We've got negative 3 for that b value there, plus or minus square root of negative 3 squared, minus 4 times the a value 2, times the c value negative 5, all over 2 times 2. So negative 3 is 3, plus or minus square root of, now we've got positive 9. Negative 4 times 2 is negative 8. Negative 8 times 5 is positive 40, so plus 40 there. All over 2 times 2, 4. 9 plus 40 is 49, no mystery there. 49 square root is 7, so that's working out good. And then 3 plus 7 is 10. 10 over 4 can be reduced, if we reduce by 2's, to 5 over 2. So there's one answer. 3 minus 7 is negative 4. Negative 4 over 4 is going to give us negative 1. So we have 5 over 2, we have negative 1, and it looks like the ing right there is also getting crossed off. So that's 2 ings that are gone. They just don't like ing. We're on to number 10 now. Use the quadratic formula again, because why not? We just keep using it here. We've got negative 5 now for that b value, plus or minus square root of 5 squared, minus 4 times the a value 3, times the c value 1. So that c value not making much difference. All over 2 times 3. So that's negative 5, plus or minus square root of 25, minus 4 times 3 times 1, that's minus 12, all over 6. 25 minus 12 is 13. 13 is not a perfect square, has no perfect square factors, so we're done. Negative 5 plus or minus radical 13 over 6 is this ath one right here. We'll cross that off, and it's on to the final problem. So for this one, we will use the quadratic formula just like everything else. So there it is one more time. Y equals all that. And then we've got negative 2 for that b value up there, plus or minus square root of negative 2 squared, minus 4 times the a value 3, times the c value negative 8, all over 2 times my a value of 3. So that's negative 2, which is 2, plus or minus square root of 4, and then negative 4 times 3 is negative 12. Negative 12 times negative 8 is, I'm not really sure, so let me multiply these in a different order. Negative 4 times negative 8 is 32. 32 times 3, I can do that one in my head. That's 96. So we have a plus 96, all over 6. 4 plus 96 is 100, and I know that's square root. That's 10. So 2 plus 10 over 6, that's 12 over 6, which is 2. 2 minus 10, that's going to be negative 8 over 6, which reduces to negative 4 over 3. 2 and 4 over 3, I see that right here kind of in the middle, so that's Bo is gone. All right, it's time to solve the riddle. What is a metaphor? So looking at our remaining letters, we have T-O-K, E-E-P, C-O-W, and S-I-N. So not a lot to work with. So I don't know that T-O-K is all part of the same word, because toki, tokip, I think what we've got going on is the word to, and then K-E-E-P is keep, and I don't think anything after that is part of that same word. So I think to keep is our first set of words, and then we have cow, that's a word. Is at the end of the word, the next word is S-I-N. To keep cow sign, I think there's an S that goes on cow, so cows, plural, and then that leaves I-N for the last word, in. So what is a metaphor? To keep cows in. It took me a few times on this one. I think meta is like a play on the word meadow, like if you're from Massachusetts or something, what's a metaphor? To keep cows in. There we go. Till next time, Mr. Sutton signing off.